Hey everyone, I hope you're doing well. So today I want to discuss few things with you regarding EFI. So there is a lot of talk about EFIs and how expensive they are, and I'm here to tell you that it doesn't have to be expensive. You don't have to reinvent the wheel. There is a lot of good parts out there that you can use and adapt to your project. The number one key to success in turning any engine into EFI is to minimize fabrication as much as possible. And how you do that, like I mentioned, by not reinventing the wheel. So I usually work with smaller engines, two-stroke engines, specifically snowmobile engines, because they are pretty powerful. They give very high density power in relation to their weight. And the problem with snowmobile engines that they are notoriously hard to control, and especially the older models that's carbureted. The engine itself might be fine, but it's not easily controllable. You don't get good idle. You have to mess around with carburetors a lot. And EFI just changes the engine, just makes it much more reliable, makes it much more user-friendly and usable. You can get so much use out of a good engine, like an Arctic Cat or something similar. You can apply it to any application you want. I like two-stroke. I work with two-stroke a lot, and I'm really familiar with them. And I just want to show you one that I'm working on. So I always start with something familiar. So this is a throttle body. I'm not really sure what brand this came out of, but it's Mikini. Yeah, Mikini. And I just want to give you a quick rundown of what to expect and how I adapt it to any engine. I know it looks complicated, but it's not. It's just a bunch of wires, but it's pretty easy. So this is the throttle body itself. So I got this out of a motorcycle. I can't remember which motorcycle, but I go to the junkyard basically, or find stuff online, and I clean it and repurpose it. And this is a throttle body with two injectors already in it, so that saves a lot of money. And you have here the fuel rail, which is pretty convenient. And this is the TPS, which is the throttle position sensor. So basically, when these cables open the throttle body and close it, this sensor here sends the position of the throttle through these three wires to the ECU. So for the ECU, I am familiar with micro squirt. I know some of you guys might think Speedwino is a lot cheaper, but that's not the case. Last time I checked and I wanted to buy something cheaper than the micro squirt, it was almost the same price. Micro squirt was just a little bit more expensive, but it's user friendly, and I'm used to it. And so micro squirt for me. So let's talk about the sensors in the throttle body. So the first sensor is the MAP sensor. MAP is manifold air pressure sensor. So this is a GM sensor. If you're interested, let me know. I can put a link. It's less than $20 from Amazon, and I just glued it to the body. So this is the only thing I changed. And the reason I changed it and I didn't use the one that came with the motorcycle throttle body is because the settings for this MAP sensor is already stored on Tuner Studio, so it's just much easier for me, and it hooks directly to the vacuum line from the throttle body here. So that makes it much easier for me to recognize and tune later on once installed in the engine. And the second sensor is this stepper motor here. It's idle something like so basically there is a stepper motor here that opens and closes to control your idle right here, and there is 4 wires that come out of it. These 4 wires are 2 leads, 2 separate leads. Each pair control one coil to control this stepper motor. So this here is an adapter that can communicate between this idle sensor or idle valve and your ECU. So there's only 4 wires that come out of it, 2 coils each, like I mentioned, and it's connected to this adapter, and from this adapter it's connected to the micro squirt, and the micro squirt sends the signal to this adapter, and this adapter controls the idle valve to give you very smooth idle. And what else? We have like I mentioned, the TPS, the map sensor, and then the valves. You have 2 injectors here, and then you have your throttle here. So I just used the same cables that came from the same motorcycle. I mean, I don't know if it was a Kawasaki or something like, or a Ducati or something like that. So basically, again, you don't need to reinvent the wheel. You don't make it hard for yourself. If there is a complete assembly, just use the whole thing, you know. So the hard part would be, it's not really hard if you did it once and you know what you're doing. How do you mate these throttle body to any engine? And the answer is, of course, 3D printing. So in my case, I just took this shape here and I 3D printed this adapter. As you can see, this adapter is offset a little bit because the intake ports on my engine are actually wider than this throttle body. So this actually bolts to the engine. This set here, these 2 screws bolt to the engine, and this bolts here. So of course I only use this just for test fit. Once I'm comfortable with it and I know it will fit, I send my design to JLC 3DP, which is amazing, guys. I am not sponsored or anything. This is a very small channel, but I'm just letting you know that these prices are very cheap, and they 3D print in titanium and stainless. I usually opt for stainless because it's much cheaper and it's very robust. And as you can see, this is a 3D printed part in stainless. I just received it today and I'm very pleased with it. This is the plastic one that I printed, and this is the stainless steel one, which is amazing that I can get this part printed in stainless steel. And here you can see the surface finish is amazing. It has all the contours and all the features in my design, and it's pretty amazing that you can get something like that, that complicated shape made in stainless steel and shipped to you. And these 2 adapters cost me $69, which is amazing. Of course, you have to pay for shipping and customs and stuff like that. So it ended up being like $160. So it's still a good deal in my opinion, because fuel and oil will be sprayed through these adapters, and you don't want to use plastic for that. I mean, it's going to deteriorate and it's going to inject some of this resin into your 2-stroke, and then you're just going to ruin your entire engine because of that. So this is absolutely worth it. I really like them. So what I do usually when I get these adapters, I put blue dye here, and then I just sand it on a flat surface like a piece of glass or something until I know that it's completely flat. And I cut these gaskets here out of rubber or silicone. I don't know what material is that, I forgot, but that's basically what I use for gaskets all the time. And I cut this on my laser, and as you can see, it fits perfectly here. And yeah, that's pretty much it. So that's basically what you get with 3D printing, and you just install it. Like this, and voila, it's ready to be installed on an engine. The second part in making EFI conversion is your air filter and plenum, and you have to make sure you fabricate something that will match the throttle body that you picked. Probably this is the only fab job that I did in the entire project. Let me just zoom out here just to give you a bit of perspective. This is just a standard air filter here, and yeah, I keep it covered in plastic until I'm done with the project and ready to fire up the engine. And I thread here a IAT sensor. IAT stands for intake air temperature sensor. So basically that's the other sensor that you will need. And on the engine itself, you will need a sensor to for the crank position sensor, and you will also need an AFR sensor. So let me get the exhaust and show you how it looks like. So this is my exhaust here, and in my previous video I showed you how to weld a punk to it, and this is my AFR sensor or O2 sensor, whatever you want to call it, air to fuel ratio sensor. And again, this will bolt, or this will be connected to my ECU to determine how rich or lean the engine is running. And that's pretty much it for an overview how to do it cheaply. Stay tuned, subscribe, and we'll fire this engine together and I will show you how to tune it. Thank you very much for watching.